Hi everyone, welcome back to ThankFlip GAMSAT's ACER Explained. So today we're going through section 3 of the practice question booklet by ACER. And if you don't have that in front of you, pull it up so that you can follow along as we're going. In this video, I'm going to be going through Unit 2, so that's questions 6 to 8. So if you haven't watched Unit 1 already, you can go back and watch Unit 1. But yeah, let's get started on Unit 2. So starting off with Unit 2, so question 6. Unit 2 is showing us an acid dissociation equation, a general one, and the question itself is asking us which of the following is the strongest base. So out of the 4 answer options that we have here, which is the strongest base? So we need to first of all consider the pKa values because we're given the pKa values of these molecules here, which as you can see look pretty similar to these ones. So if you are familiar with acid-base chemistry, you'll recognize that these values here are the conjugate bases of these acids here. All right, so keeping that in mind, first of all, let's figure out what the pKa values mean. So a higher pKa means that the acid doesn't readily dissociate, which means that the acid is weaker. Okay, so Ka is the dissociation constant of an acid, and the higher Ka is, the stronger an acid is. Because the stronger the acid, the more readily it will dissociate into its ions. All right, so pKa is the negative log of Ka. So that means that they have an inverse relationship. So the higher Ka we have, the lower pKa we're going to have. And that means the stronger acid we're going to have. All right, so this is kind of out of our equation for now because we're not given Ka, so we just have to kind of think of this relationship. So there's an inverse relationship here, okay? Now, what does this have to do with the conjugate bases that we have here? Well, using your foundational acid-base chemistry knowledge, it's important to remember that the stronger an acid is, so the conjugate base of a weak acid is going to be a strong base, whereas the conjugate base of a strong acid is going to be a weak base. So if we have a strong acid here, then the conjugate base is going to be weak. I like using these arrows because it makes sense of things quickly in my head, and so this could be useful for the GAMSAT when you're trying to sort through a lot of information. So having little notations like this can be quite useful. So conjugate base of a weak acid is a strong base. Conjugate base of a strong acid is a weak base. So given this relationship here, we can kind of simplify that and say that the lower pKa of the acid, the weaker the base is going to be. And the higher pKa of an acid, the stronger the base is going to be. Right? So if we want to find the strongest base out of these, we basically just need to look for the strongest or the highest pKa. And here, this option here has the highest pKa value, which means that its conjugate base is going to be the strongest. So we can circle D and move on. So as I said before, knowing your pKa and acid-base chemistry principles is prerequisite knowledge here, and it's really your bread and butter for the GAMSAT chemistry. So a resource on the Bootcamp that can be useful for this is the acid-base chemistry bridging course and content in action. And some reasoning skills that were used here were extracting the important information, as well as process of elimination, which you could have used. And these skills can be developed through the reasoning skills course on the bootcamp. So moving on to the next question. So in this question, we're being asked to figure out which one of the following answer options has the correct relationship between the two molecules, and this is in terms of acid strength. So that would mean that, for example, with option A, it's saying that this molecule here is a stronger acid than this molecule here. So we have kind of looked at acid strength in terms of pKa values, and so we're given the pKa values of these molecules. However, you will quickly find out that it's not too relevant to this question. So now we have to use some other information that's given. And so the other information that's given is that the more stable a carboxylate group is, the stronger the acid is going to be. The carboxylate is a product of the acid dissociation. So it's saying that the more stable the products of the acid dissociation are, the greater the acid strength is going to be. And so another thing we have to consider is that an electron withdrawing group stabilizes the carboxylate, and an electron donating group destabilizes the carboxylate. So electron withdrawing groups are going to be molecules or groups of atoms that are highly electronegative. So that means that electronegativity refers to the attraction that an atom has to electrons. So it's going to pull electrons towards it. And so that means it's going to be electron withdrawing. So looking at our groups here, we want to make sure that they are electron withdrawing and not electron donating. But starting with option A here, we're going to go through the process of elimination. So we have this molecule, which you might be able to use your pattern recognition skills and realize that this molecule is very different to the other molecules. And that's because the structure here is actually, so we have CH2, so I'll draw out the whole thing, and then we have OH, then we have CH3. So this is actually an alcohol, not an acid, not a carboxylic acid. So our acid would be COOH, and then we'd have the CH3 over here on this side. And so in our stimulus, you'll be able to see that the electron withdrawing group refers to this group when you have this group present. So because this one doesn't have it present, you can kind of disregard this. And also, you can use your acid-base chemistry knowledge or your basic physical chemistry knowledge to realize that alcohol is not a very strong acid, right? And because it's an alcohol as well, even if you don't know exactly the, I guess, Ka of an alcohol, you can kind of tell that because this one is an acid and this one is not even called an acid, it's called an alcohol, you could tell that this is not going to be true. The alcohol would probably not be more acidic than the acid, right? So you can kind of eliminate this for now. That's if you didn't have that prerequisite knowledge of alcohol, of the fact that alcohol is a weak acid. They're not strong acids. Okay, so that's how we eliminate the first option. Then looking at the second option, we have this molecule here. So that is fluorine. So fluorine, if you know, is highly electronegative. And so this atom here, this molecule here has one fluorine, whereas this molecule here has two fluorines. And otherwise, it's pretty much the same other than the number of hydrogens, but that's not going to make much of a difference. So you can reasonably assume that the molecule with two fluorines is going to be more electronegative than the one with one fluorine. And that's going to stabilize the carboxylate group more, which means it's going to be a stronger acid. So we can assume that this answer seems pretty good so far. But let's continue just in case. So going to the next one here, you would also need to have the knowledge that a methyl group is going to be electron donating, especially because it's only a kind of single bond. It's going to be an electron donating group, or it's not going to be very electron withdrawing at all. So having this extra group here is probably not going to make much of a difference, and so this is likely going to be incorrect. Or if you're unsure, you can kind of use your reasoning in that this is not going to make as much of a difference as two fluorines, right? Because you should know based on your kind of periodic table knowledge that fluorine is extremely electronegative. So this is still the best option, this one here. Okay? And similarly, you have an iodine here. And so the iodine being added here is also not going to create much of a difference in electronegativity either. Similar reasoning to option C. And so option B is still your best bet. And this one's a bit tricky as well, because you might believe otherwise. But, you know, the point of the questions is to select the most correct option, right? So the answer is going to be B. And yeah, you can move on.
So the previous knowledge required for this one was pKa and acid-base chemistry principles, just like before. And it was also important to know about electronegativity as well as the periodic table, especially in terms of which elements are more electronegative. This is quite high yield because often in the GAMSAT, they won't actually give you a guide on which atom is more electronegative, and you might have to use that previous knowledge to figure some things out and reason with the information that you are given. So one place that you can learn that is the acid-base chemistry bridging course. And then the reasoning skills that were used here again were extracting important information, as well as process of elimination and pattern recognition, which you can all you can develop all of these skills in the reasoning skills course on the bootcamp. All right, next question.
So question 8 is asking us about the correct order of acidity for the below compounds. So we want the most electronegative carboxylate group or the most electron withdrawing for the most acidic compound. This is because, again, the stimulus told us that the acidity of a compound depends on the stability of the carboxylate group, and also that an electron withdrawing group stabilizes this carboxylate group. So let's look at the differences between these three compounds. And the only real difference you'll realize if you're looking, with the lens of your pattern recognition skills, is that the carbon bond here is the only thing that's changing, right? Otherwise, it's the same exact molecule. And so it's important to note that different bonds have different electronegativities, and triple bonds have the highest electronegativity. Double bonds have a little bit lower than triple bonds, and then single bonds have the least electronegativity, or they're the least electronegative. And so you can kind of see, if you know that, then you can say that, all right, well, I has a single bond, so it's going to be the least electronegative, so you can already figure out that D is probably your answer. But then you can confirm this by going in and saying that, all right, well, this number 2 has a double bond, so it's going to be kind of in the middle. And then number 3 has the triple bond, and so that's going to be the most acidic, or the most, it's going to have the most electronegative, or the most electron withdrawing group, which is going to stabilize the carboxylate the most. So this one is going to have the most stable. This one's going to have the most stable carboxylate, which means that it's going to be the strongest acid. And now, if you didn't know this, you could also use the process of elimination to kind of actually figure out or eliminate 2 of your options, all right? So you can see that the only difference between these 3 are the bonds here. And you can see that number 1 has a single bond, number 2 has a double bond, and number 3 has a triple bond. So there's some sort of pattern that comes with that order, most likely, right? And so even if you didn't know that single bonds are the least electronegative and the triple bonds are most electronegative, you could at least ascertain that your answer is going to be either A or D, because it maintains that order of 1, 2, and 3. And this one is 3, 2, and 1, because you can see that the only changing thing here is the bonds, and that's kind of in order of 1, 2, and 3. So even if you didn't know the actual electronegativity of the bonds, you could at least eliminate these 2 and guess between A and D. So using some of your reasoning skills there.
So for this question, you could have had the prerequisite knowledge of bond electronegativity. However, this is quite a niche topic, and I wouldn't be surprised if you didn't have this prerequisite knowledge. So this question was definitely more about your reasoning skills, so looking at pattern recognition and using the process of elimination to get to those final two answer options that you can guess between. And unfortunately, this is going to be the case for a lot of your GAMSAT questions where you're using your reasoning skills to get to the final two options or to eliminate as many options as you can to then give you the best chance of guessing. But the bootcamp resource that you can use to hone this sort of skill so that it's not pure guesswork is the reasoning skills course, as I've been mentioning all throughout this video, as well as the acceleration class for pattern recognition more specifically. So that brings us to the end of Unit 2. Please give us a like if you did like this video for some feedback. Feel free to give us feedback in the comments and also subscribe so that you're not missing out on any of the newer videos that we're posting about the GAMSAT. And feel free to share this video as well with some of your GAMSAT study buddies for some GAMSAT help. We have our Instagram at ThankFlipGamSat and our podcast, ThankFlipGamSat Nurses Doing GAMSAT. And you can find this at www.thankflipgamsat/podcast. So that's there if you want more information as well. See you in the next one.